eMOLT stands for Environmental Monitors on Lobster Traps and Large Trawlers.
That's George Menard, eMOLT Coordinator for the National Oceanic and Atmospheric Administration, NOAA. He's based at the agency's Woods Hole Center, connecting the dots between ocean data, fishermen, and scientists.
The goal of the program is to put sensors onto commercial fishing gear to collect data that informs fisheries management, fishing effort, and oceanographic forecasts.
The effort has been gathering data in a low-key way for decades, but more recently, a grant from the Massachusetts Technology Collaborative enabled it to grow from 30 to 145 vessels last season, embracing all the comforts of current technology while also strengthening an alliance between those who study the sea and those who make their living upon it.
We have participating vessels from Maine to North Carolina.
How many?
145.
Wow.
Yep. So it's grown a lot. The sort of Massachusetts Technology Collaborative grant that we got in the last couple of years enabled us to really expand the program. I spend maybe 20 days a year at sea, but there are fishermen who spend 200 days a year at sea, and so that's when I'm behind the desk, they're seeing what's actually happening, and so if they can collect the data in a way that we can use it, and then pair that data with some of these anecdotes about, oh, I saw this weird fish in this place, or my gear behaved a lot differently and I'm not sure what's going on, or I found this new type of seaweed that I've never seen before. Those kind of things, those observations, along with the actual hard environmental data can be really helpful.
That's the heart of eMOLT, a collaboration that connects a scientist's need for quantitative data with a fisherman's on-the-scene observations.
This cooperative research is a different way, I think, for the industry to interact with the agency that's maybe not as antagonistic as the management process.
Today we're here in East Falmouth at the labs of Lowell Instruments. Nick Lowell, company founder, began working on data loggers for the project in 2012. He says advances in sensor technology, open source hardware and software, and the impact of cell phone tech combine, letting the team bring a flexible, extensible, affordable, and durable product to sea.
A data logger is a device, electronic device, battery powered typically, that can take measurements and store them on the device. So there's been a lot of progress in the technology, particularly driven by cell phones. Sensors are relatively inexpensive, low power, and very capable. So we were able to take advantage of using some of these new sensors to make a new data logger. This device was designed for use on fishing gear. This version is rated to 300 meters depth. It's about the size of a 12-ounce soda can. It's temperature, depth, and orientation. So this device can, with its temperature probe, can measure temperature, and it's fast acting, so it can record it quickly as it moves through the water column.
The first years of eMOLT featured paper, snail mail, and very early sensor tech. And the tools have just kept evolving over the decades.
So eMOLT came to be through the work of Jim Manning, who was an oceanographer at the center who retired in 2022. Jim worked on a bunch of oceanographic cruises, on the big NOAA white ships. When he was out there, he would see fishing boats operating around them, and he was wondering, what goes on those boats? What are they interested in? What are they curious about? And so Jim started going down to the docks and talking with fishermen. He had these mini log sensors, which were made by a company called Vemco up in Canada. They're about this big, and he started giving them out to lobstermen to zip tie into their traps. And so these lobstermen would zip tie the sensor into their trap. They would fish it for the whole season as they normally do. And then they would write down on a paper log, this is where I set it on these, these dates at this depth. And some of them even included this is how many lobsters were in it each time they hauled it. So they would send that data sheet, handwritten data sheet, along with the sensor back to Jim at the end of the season whenever they hauled out for the year. Some of those sites are now, they have 25, 30 years of data almost.
Today's technology brings more complex and automated functions, replaces that snail mail with the cloud, and lets people share information in near real time.
It has a depth sensor, that's the white disc there, which is a pressure sensor. So it measures depth by looking at changing pressure. And then internally, it has a three-axis accelerometer, which is very similar to what you have in your smartphone. So it knows which direction is up. If we don't have sensors in the ocean, we don't know what's happening. If we don't know what's happening in the ocean, then we don't know why are various species of fish, maybe, trying to understand why are they here and not there. It's battery powered, runs on 2 AA batteries, and critically, it is Bluetooth enabled so that it can communicate wirelessly to other computers. A good example that a lot of people on the Cape are interested in is the striper migration, right? It's almost May. It's about time to be thinking about going catching your first striper, at least one that isn't a holdover. But it's very temperature driven. But there are many species that are temperature driven. The black sea bass, for example, have been generally moving further north. That's believed to be because of warming waters. The black sea bass like warmer water than we've typically had, and you see a lot more of them. So internally to the device, there is a two AA batteries and a Bluetooth radio, and the temperature sensor is wired into the circuit board, the pressure sensor is wired in, and there's the accelerometer that gives you the second part of our system is what we call the deck box, or the deck data hub, which is a low-cost computer that's designed for downloading, viewing, and pushing the data up into the cloud for other people to analyze. This is typically mounted in the wheelhouse of a fishing vessel. When a new data logger appears, it automatically connects to it, downloads the data, and makes it visible for the fishermen. You can then switch over and look at the graphs. So this is some data from last fall. Let's go back to that. This is data from last fall, and the red is the temperature. So the temperature shows that it fell from about 60, 61 degrees Fahrenheit down to 57 to 58 degrees.
From the data, we have been able to improve the performance of some of these ocean forecast models. The models are performing better. That means fishermen can trust them more when they make fishing decisions or use them to make decisions about where they're going to fish. And scientists who are using them to model fish populations can also trust those outputs more.
The most important thing that we've done with this system is we've made it so that it's really easy to collect this information. So you take one sensor, let's say, and depending on the fishery, this again could go into a lobster trap. It could be attached to the trawler door of a typical dragger. It could be using a bracket welded onto a scallop dredge. But once you've done that one little bit of setup and you have your deck box, there's no work that has to happen. Like, it all works automatically while you're fishing. So the data collection cost and effort is really low. In an hour or two on the fishing boat for this initial setup, you're now collecting data for months and months. And that's huge. All the data that's collected by the eMOLT program is then incorporated in ocean models. There's a zoomed in view of the Cape region. What this model is showing is what the model believes the bottom temperatures are.
For the next 72 hours.
For the next, 3 days.
We've also seen some really interesting applications of the sensor technology by the fishermen themselves. So clams spawn at such and such a temperature. I don't want to catch them while they're spawning because the meat yield is low. So I'm going to fish. If I see that the temperatures are over that threshold, I'll move somewhere else, wait till it's colder. As Nick kind of alluded to, we're on just about every type of commercial gear that's fished in the Northeast. Lobster pots, fish pots, gill nets, long lines. The pelagic long lines, those are up in the water column for swordfish and tuna. The bottom long lines, trawlers, scallopers, clam dredges, pretty much run the gamut.
Other methods of collecting data tend to be a lot more expensive. So if you have a oceanographic buoy, let's say, the oceanographic buoys, 6 figures probably to get one, on the order of $300,000, $400,000, $500,000, depending on how fancy the buoy is. That has to be taken out by a giant ship, placed there, then it's going to have to be maintained. And that cost is, the maintenance costs alone are hundreds of thousands of dollars as well. So the cost is exorbitant. One fishing vessel, you can get that going for about $3,000 to $5,000.
NOAA doesn't manage the data, or is not the steward of the data that's collected by this program. It's another thing that makes it unique. The data are all managed by the Gulf of Maine Lobster Foundation, which is a nonprofit that's based in Kennebunk, and their board of directors is commercial fishermen from Maine, New Hampshire, and Massachusetts.
Data matters because if we don't have any good data, we're really flying blind as far as trying to understand what's happening in the ocean.
Cooperative research is good not just for collecting data that's not otherwise accessible, but also for building those bridges, building trust. Ultimately, we're all working towards the same goal, which is we want to have economically and environmentally sustainable fisheries that help coastal communities maintain themselves. Everybody wants that.